Hey everybody, this is Team FBC 5795 and I'm Zeel Patel, and we're continuing with our FLL Robotics lessons. This is week 2. In this lesson, we're going to talk about the different sensors and other motors that are used in EV3 robots. So the first one is a touch sensor. So on the right, you can see a picture of the touch sensor. The touch sensor gives your robot a sense of touch, and that touch sensor can also detect when it's being pressed or released. It can even be programmed to wait until the sensor is pressed and then released, and that function is known as a bump function. And the color sensor. The color sensor is a lot more complicated than the touch sensor. So color sensors can detect either the intensity of the color of the light, and the color sensor also has 3 different modes, which is color, reflected light intensity, and ambient light intensity. So the color sensor can detect up to 7 different colors. Those 7 colors are black, blue, green, yellow, red, white, and brown. And each color is represented by a value from 0 to 6. And then reflected light intensity. So the color sensor emits a red light and measures the amount that is reflected back into itself from the surface you're testing. And so that intensity of the light is measured from a percentage of 0% to 100%. And 0% means it's a dark color, and 100% means it's a very bright color. And then you have ambient light intensity. So it's kind of similar to reflected light intensity. However, the color sensor measures the amount of light in its environment without producing its own light source. So similar to the reflected light intensity, it's measured as a percentage from 0 to 100. And like before, 0 is dark and 100 is very bright. The ultrasonic sensor. So the ultrasonic sensor measures distance up to a maximum of 100 inches, and it does this by sending out high frequency sound waves that bounce off any object in range and measuring how long it takes the sound to return to the sensor. So in the software that's like you can use as like a download source if you want to test, because we'll be doing videos. It's called EV3 Mindstorm Programmer. You can select whether the distance is given in centimeters or inches, and that ultrasonic sensor also has a listen only mode that can detect whether another robot is using an ultrasonic sensor nearby. And so in this mode, the sensor only listens for signals but doesn't send them. So the gyro sensor. The gyro sensor is arguably one of the more complicated sensors in all of FLL. So the gyro sensor detects rotational motion in the plane indicated by the arrows. So the arrows are kind of hard to see, but they're on the top part of the sensor. You won't be able to see them very well in this picture. But the sensor measures the rate of rotation in degrees per second. And it also keeps track of the total angle of rotation in degrees. So a tip is if you do choose to buy if you do choose to buy the EV3 kit, when you connect the gyro sensor to your EV3 brick, hold it completely still in order to minimize your drift. And so for the best results, reset the angle using the reset mode of the gyro sensor block before every angle of motion you want to measure. So the infrared sensor, it looks kind of similar to the other sensor right here, which is the ultrasonic sensor. The ultrasonic sensor looks like it has eyes. This one looks like it's squinting. That's kind of the main difference. But the infrared sensor obviously detects more heat. The infrared sensor measures the distance or detects signals that are sent from an infrared beacon. The infrared sensor can be used in 3 different modes. The 3 are proximity, beacon, and remote. So proximity, the infrared sensor sends an infrared signal and detects the reflection of the signal by an object in front of the sensor. And then the strength of the reflected signal can be used to estimate the distance to the object. So again, the maximum range is approximately 100 centimeters, similar to the other sensors. Beacon mode is when the infrared sensor can detect an infrared beacon set to beacon mode. And then the infrared sensor can detect the beacon's proximity, or like the relative distance from the sensor, and where it's heading, so the angle from the direction the sensor is pointing. And then in remote, the infrared sensor can detect button presses on the IR beacon. So the infrared sensor can detect which button on the remote infrared beacon is pressed. And in addition, you can detect when certain combinations of 2 buttons are pressed at the same time. And so this is the infrared beacon. The infrared beacon is an infrared transmitter and can be used in beacon mode or remote mode. And so in beacon mode, the beacon transmits an infrared signal continuously until you press the beacon mode button again to turn it off. In remote mode, the beacon just can be used as a remote control, like similar to like a PS4 or Xbox controller. And then the infrared sensor will only detect a beacon on the channel specified in the software. So if two robots are remotely controlled by two different infrared beacons, they should be using different channels. Otherwise, one beacon will control both the robots on its channel. And tip, so the beacon mode button acts differently to the other four buttons. So when you press the beacon mode button, the beacon starts transmitting continuously until you press it again to turn it off. The other four buttons only transmit when they are held down and stop transmitting when you release them. So that will do for the motors, or not the motors, the sensors. Come back for another video later in the week.